Some stuff might be too basic for you. You might think, I already know that stuff, but maybe somebody else doesn't. So, if someone's got a bunch of questions, just let them ask and try to be patient. And then maybe some stuff's going to be like, you don't understand it. So, don't feel bad about asking questions, or, maybe I'm not explaining it well. And then also, I'm going to be emailing the presentation and the video, so if I skip a slide that you wanted to see, you can always check it out later. So these are just the basic topics we're going to cover. Thank you, sir. So this is pretty general over what we're going to cover, but we're going to talk about speakers, the placement and the coverage, power requirements for all those speakers, because that's basically what we're worried about, is powering the speakers. Wireless microphones, because we can get into a lot of issues with wireless mics. We're going to talk about ringing out the room and just EQing for audio quality and for different speakers. And then we'll talk about analog and digital mixers and just a bunch of different routing things you can do on both. And then just a lot of tools and apps, software, and tips that will help you a lot. And a lot of them are free. So just a basic overview of like the frequencies that we deal with. Audio goes from all the way down to 20 hertz to 20 kilohertz. But for the most part, we just deal with a voice. And the lowest that goes is 80 to 100 hertz. But music, we still deal with music in a show. That still goes down to 20. But just keep in mind that a voice, it has a certain range within all the frequencies. And down at the bottom, you can see there's a male voice and a female voice. And they kind of hang out in different ranges there. So just be aware that they don't cover the entire spectrum of human hearing. And that'll come into play later when we're EQing. That you don't have to look for frequencies in the 30, 50, range when somebody's speaking. You can just kind of get rid of all those. So if you know kind of a range of where the voice should hit, that'll help a lot. And then these, slide around. So, your voice might fall in this range, but maybe, it's a woman and she's got a deeper voice, and, this range might be down to here. So this is just kind of a general overview. So on the speakers, this is just a, general basic setup of how you would set up a room. You've got your left and your right, and the audio that comes out of there is usually at somewhat of a fixed angle, something like 90 degrees. But, obviously you could still hear out in this area or in this area, but this is where most of the intelligible audio is coming out. So we're talking about coverage, covering the seating here. These are all the seats here. And in this instance, you've got good coverage. You've got this left one covering over here, the right one coming over there. Everyone is getting audio. What happens a lot of times is, we place the speakers and maybe the stage gets dropped later, and your speakers are actually on the back edge of the stage. And if we show those two triangles again of where the audio is coming out, you start hitting the stage. And because you can hear outside of these coverage areas, it's actually hitting a lot of the stage, probably all over here. And that's how you can get feedback issues. You know, if somebody's standing with a microphone in front of any speaker, you've got potential for feedback. So basically rule one is, you know, keep all the speakers in front of any microphones, and that'll eliminate a whole lot of feedback issues. So moving on, let's say you've got a wide room, or for some reason the PM says, I need these speakers here. You know, they're in the way over on the corners. And so your coverage looks more like this. And you're not hitting these middle seats. And the way to fix that is to add more speakers. And I label these FF for front fills. And so basically you would fill in, and you could, you know, just add one front fill. It doesn't have to be two, but just enough to cover this area in the front here. And what you would want to do ideally is, with any set of speakers, have them all on a separate control. Because these front fills, maybe you just need to hit this area here. So you want these speakers at a pretty low volume. So if they're all tied together, if you just hopped all these speakers together and you only have one fader, you know, you don't have any control over separate volumes. So I'd usually have a left, have a right, and then you could tie these two together and have a front fill output. And for whatever reason, maybe a presenter walks down in front of this speaker and you just want to lower this volume real quick and have the rest of them producing the same volume. You could just bring down that left fader so he doesn't walk in front of that beam, and you know, you hear feedback. So as much as you can, you know, put every speaker on a separate output. So here's another situation where, you know, they've put the screens up and they don't want your speakers down in these corners because you're blocking the screens. You know, they're up on stands and they say, get these out of here because these people can't see that screen and these people can't see that screen because you've put them over here. So they say, we need them outside of the screens. So you put one over here and you put one over here and you angled them in to cover everywhere, but you're running into the same problem. All that audio's spilling out all over the stage, and you're going to get feedback issues from all this audio going back into the mics. So in this situation, you would do the same thing. You would add front fills, because to solve that, you would turn these speakers away from the stage. They're not hitting the stage anymore, but you have this gap. And then same thing, you can add some front fills again. So, you know, every single room is different, and you basically have to fudge things around so everyone's got coverage, everyone can hear, and really the more speakers the better. You don't want to, you know, make speakers cover areas that they shouldn't be covering. So if we're looking at, that was like a wide room, this is a long room. So we're looking at it sideways. And let's say this distance is really far. You know, it's a long, long ballroom. This decibel level in the front, let's say it's 70 decibels, just like a normal speaking level. For the people in the back, it's not loud enough, you know, and you get that all the time. And you're standing at the back of the room and you're like, well, we need to turn these speakers up because we can't hear back here. But then obviously you start blasting these people in the front and you're like, well, what's the solution here? Like, someone's going to lose out. And so you add in some delay speakers. So instead of adding two for width, you add them for length. So you'd put a delay further down, maybe halfway down in the room. And I usually put them at a lower level than this is, because if this was the same level, if this was 70 decibels also, and you're sitting right here, it's a little distracting because you're looking at something up on the stage, but the sound is coming from somewhere else. So if you keep delays at a lower level, it still sounds like the audio is coming from the stage, and this just kind of fills it in for you. And that's just an arbitrary number, 5 decibels down, but I just wanted to show that usually just at a lower volume. And then the problem with adding these delay speakers is if you're sitting here, this audio is coming out of this speaker, and it's also coming out of that speaker at the same time. So you're going to have a time difference, and it's going to sound like wafty, kind of, echoey, and it's not going to be intelligible sounding. So you want the audio coming out of this speaker to be delayed, and that's why we call them delays. So basically, the audio comes out of this speaker, and by the time it gets to this speaker, then this one kicks on and sends out the same thing, so that they send it out together. Because if you didn't add a delay, by the time this audio got to here, the audio from this speaker would be out here, and they're not time aligned. So if it is for just coverage, let's say it's a little bit of a long room, but it's not, a huge general session. You just kind of want to add a little bit of volume in the back. You don't necessarily have to set these as a delay and put a delay time on them. If you just want to put these in a room to get these last few rows, you can do that and not set a delay time, and it won't be noticeable. But the longer the room is, the more this is going to be apparent that they're arriving to you at different times. So this is just a simple equation how to figure that out, but you could also just download a table. So you basically measure the distance from your first speakers to your delays. Let's just say it's 60 feet. And you look up on the table, 60 feet. I delay them 53.6 milliseconds. So this is it's a super small amount of time. It's like you can barely, measure that distance, but you can hear it. Your ears can hear the difference between that. So basically, audio comes out of here, and these wait for 53.6 milliseconds, which is how long it takes audio to travel to here, and then they join together and send out the same signal. So here's that equation. But yeah, I usually just have a table on my phone so I can quickly know. And the other thing with delays is when people say, we've got to time align the speakers, it doesn't make any sense, because you can time align the speakers for someone sitting right here, but for a guy sitting down here, he's a different distance from this speaker and a different distance from that speaker. So you'd have to time align it for that guy. And so everyone's sitting at a different spot in the room, and it's never going to be time aligned for every single person. So in general, you would just time align it for one area. You'd pick one, somewhere in the middle of the room near the back, and say to yourself, does it sound in time in this area? And if you do that, people over on an edge or that are really close to a speaker, there's going to be a little bit of time difference, but that's as close as you can get. Is just set it for the middle of the room. So yeah.
Set your sound algorithm here for about 1,000 feet per second.
So it's 1130, yeah. And that, they say it fluctuates, well, not they say, but it does fluctuate depending on temperature and humidity. But
sea level.
Yeah, and sea level. But it's such a small amount that you don't need to measure the temperature and see what elevation you're at.
But you should use your ears to make sure it's
Yeah. So yeah, one thing that I do is just on YouTube. It's just a wooden block, and I think it's called like wood block beats per minute. And you can say it's just a wooden block being hit at like 40 beats per minute, just at a regular interval. And I just play that, and that's what you want to do, is play something it hits once and it's or a snare, and then you walk around the room and see if it sounds like it's coming from one place, or does it sound like you hear bump bump.
You got a ping pong thing.
Exactly, yeah. So that's the best way to test this once you have it set. Or you could play something like that to see if you even need to set a delay. You might set up just some, we'll call these outfill speakers, play something like that, like a snare hit or a wood block, and say to yourself, I can't tell any difference. It sounds like it's all coming from the front. I'm not even going to set a delay, And this is for 60 feet. Like, that's a pretty long distance. We're talking about probably a room that's like 100 feet long. That's a huge, huge ballroom. And that's when you start getting, weird delay stuff going on. So that's just like a quick, easy test to see if you need to do it. And so, like, when we do big shows, so we just talked about the plane of the floor, where to move things around the floor, but you have to think about height also. Because when we do really big shows, or you go to a big concert, that's why they fly speakers. Because if you have them on a stick here, you're going to be blasting this person in the front, and to get a good volume for the people in the back. So to solve that, that's why we put speakers up in the air. You make this distance, the X distance, to the first row as close as you can to this Y distance. You want to increase this as much as you can. So for the most part, we're putting speakers on stands. You want to raise that up on the stand as high as you can without it, being dangerous or being in the way of something, because you're trying to recreate a flying speaker. And that way you're decreasing the range of volume that, let's say this guy hears it at 60 decibels. It might be 40 decibels back here for this guy. But in this situation, if it's 60 decibels for that guy, it might just be 55 for this guy, because they're, a similar distance from that speaker. So basically, I'm just trying to show that the lower the speaker, the more you're increasing that problem of different volume levels for everybody. And this is just like, it's not really a rule, but they say that's what they shoot for in a big concert, is you don't want it to be any bigger than a 6 decibel difference between the front and the back. So no matter where you are in a concert, you go to a good concert and you're like, you get a little bit more action if you get up in front, but it's not painful usually. And you go all the way to the back and you're like, still sounds pretty good, because that range is only, 6 decibels. But sometimes we're in a meeting and you're like, sounds great up here, and you're in the back of the room and the client's like, I can't hear anything, turn it up. And, you're getting into a problem there because you didn't raise the speaker high enough. This is just a graphic showing placing speakers near a wall. And a lot of times, we're forced to do that because they just want the speakers out of the way. And what it does is it increases the low end. So it basically reflects off the wall and increases the bass response. So if you put it near one wall, you can get plus 6 decibels of low end that you didn't want. In a corner, now you're dealing with 2 walls, and it could be 12 decibels. And if it was down on the floor in a corner, that's basically 3 walls. It could increase it 18 decibels. So you got to keep that in mind. If you've got your speakers on the, the 2 air walls, and everything just sounds boomy, and you can't figure out why you can't get rid of the low end, what I do is I just pull the speakers off the wall like a foot. And they're gonna, sometimes a PM will be like, no, we want them on the wall, and you just can avoid a lot of that buildup if you just pull it off the wall like a foot and just tape down like a foot of cable towards the wall. It doesn't look as clean with the cables, but you just get more even frequency response by doing that. And then you can also get, reflections coming off that wall. So you're getting like direct sound from the speaker, and then it's reflecting off the wall and then also to the audience. So, then you can start getting like phase issues where it's bouncing off all these walls and you're getting the direct sound, and you start hearing kind of wafty, voices. So just try to keep it, out in the open somewhere. Just a few speaker tips. Check all the gain levels of all of your speakers, because sometimes you're on a team of people, and some people are like, oh, I'm gonna crank them all the way up, because that's what I do. And then other people are like, I'm gonna put them at noon, and nobody talks about it. And then all of a sudden you turn up a mic and you've got all these different levels, and so you just want to double check all the amps or all the speakers, make sure they're all at one thing, and then you can change it all at the mixer. And like you guys know, like just keep all the cable beneath speakers, but some people don't do that, but you need to be able to move those speakers. And if you don't have any slack, or you're pulling on a cable and all the slack is like back behind the drape, and you're like pulling things out, and then just always walk the room. Like you can be at the tech table and you're talking to a mic and you're like, sounds good, and then you walk around with a mic and you're like, oh, this speaker isn't even on. Like it sounded good back there, but you can't tell until you walk up to a little front fill that like, oh, that thing wasn't even powered on, or that one's buzzing, or it's super low level. So you got to walk around and listen to everything individually. So this is just a quick thing about power. There's like a big Ohm's law graphic here. So you could just figure out anything that you don't have. Our constant is always, we always know our volts, because that's 120 in the US. So, if you know volts, you can figure out, other equations that involve volts. But we won't really get too far into that. I'm just going to touch on that. Usually we have 15, 20, or 30 amp circuits. So, just keep that in mind when you're going around and adding up all of your speakers. You're looking at how many amps each speaker pulls and how many speakers you have, and you're adding all that up to figure out, okay, how many circuits do I need? When the electrician comes by and says, is 130 amp cool? And you're like, I think so. You're just kind of guessing. You're like, it's probably enough. You got to do the math. So what you don't want to do is, you guys all know, you don't want to go over 75% of the circuit's capacity. So if you have a 20 amp circuit, your limit should be 15 amps. So here's just a little example. You got 4 powered speakers. 2 of them are 4 amps, and the other 2 are 5 amps. and you're given a 20 amp circuit. Should we use them all on this circuit? The answer is no, because they require 18, which, you know, that's under 20, but you're playing with fire because it's past the 75% threshold. So ideally you'd use two 20 amp circuits or a 30 amp circuit. And then one other quick example, you know, sometimes it's a passive speaker, and so you're looking for your specs off of the amplifiers. And basically all these specs are off of amplifiers. The powered speakers just have an amplifier in them, but that's basically what you're looking at. So you have 4 amplifiers, 3 of them 4 amps, the other one is 5 amps, and you have a 30 amp circuit. Is this cool? Yes. They require 17 amps, and you got the 30 amp circuit, so you're good. So the other thing to keep in mind is that those are the maximums that these speakers or amps are saying that they're going to pull. And we want to plan for that. We want to get as much power as we can and plan for the worst. But you can measure your speakers or amps and see how many you're actually pulling, you know, when you're setting up a show. And so basically you need a clamp meter to do that. And there's 2 different ways to measure the amps. If you're using an Edison outlet, you can get this AC line splitter. This thing's like 10 bucks. And you put the clamp in there and you push your system as loud as you're going to push it with, as, you know, the biggest frequency range. So probably music or videos. And you push it as loud as it's going to be in the room. And at that point, you clamp this and you look at the meter, and it'll tell you exactly how many amps you're pulling off of that outlet. Maybe it's way less than the speaker said they were going to pull. And then you can just factor that in. You can say, okay, I'm going to put a couple more things on this circuit because it looks like worst case scenario, I'm only pulling like 3 amps out of this thing. And then the other way to use it is to clamp it around cam lock and do the same thing, push the system as loud as it's going to be, and, you know, clamp it around each feeder and see how many amps. You know, maybe this is Video World. You could check out how many amps they're pulling. Maybe this is your tech table, and maybe this is your mains and subs or something. And, you know, you should know which one is which. And then you can say, okay, we've got a lot of room over on this one. We could move some things, you know, over to that feeder. And a clamp meter, I think you could get one for maybe like, there's somewhere between like 30, 40 bucks to like a couple $100. But, you know, it's a multimeter, so it's got the clamp meter. You can measure anything, you know, volts, amps, anything you'd want to measure, electrical.
Hey, Noah?
Yeah.
I've never seen that splitter before. I don't understand
Yeah.
what that, I mean,
So
the whole point of the clamp is you can just put it on the main cable lead and it'll tell you.
So you can't do it on an AC cable. If you clamp it around an AC cable, it won't recognize it. So
You're only reading on load wire.
Gotcha.
So the reason you can do it on cam lock is because it's all split out.
Okay.
So basically what it's doing in here is it's separating all the cables that are in there, and it separates them, you know, to wind the certain ones around these holes, and then reconnects them back here. So you basically just, what's that? Fluke? Yeah, that's a good brand. But like I bought a clamp meter and this just came with it. And then, so one hole is like exactly what you're pulling amp wise, and one of them is like a 10 times. So like if it's a really small amount of amperage, it'll still be able to tell you what it is. Okay, so moving on to mics. These are just some lavalier tips that, I'm sure you know, but, sometimes you forget. You always want to lock on your mics, never trust a presenter to turn it on and off. And then also while they're sitting, and they're talking to somebody, you could listen on the headphones, make sure it's, not rattling or anything, listen to their voice. And, you're controlling it all. It's all on you. Take off any necklaces or name tags. Make sure it's not like super taut under their shirt. So if they like stand up straight, it's going to pop off. Leave a little slack in their shirt. And then if you're, everyone's got some different weird shirt going on. And sometimes you have that option of you're like, well, if I clip it down here, that's too low. But if I clip it in this other place that I could clip it, it seems like it's too close. Always err on too close, because if it's too far away, you're going to have, feedback central. You're just going to be fighting feedback because you're going to try to bring up that fader, and it's going to be picking up all the speakers. And, it's going to feed back into that microphone. So if you have it too close, the only thing that happens sometimes if you get it like too far, right under their neck, you can get some like low end buildup, and you can just kind of EQ that out a little bit. But you'd rather have that than, feedback issues. And then, keep it centered on their shirt. There's sometimes there is no center. There's just like some shirt that's like this, and you've got to clip it on the left or the right. But, you can rotate the mic. So if it's over here and it's pointed straight up and then they decide to present like this, you're screwed. So, if you want to clip it on one side, just rotate it so it's, pointing at their mouth still. And, no matter which way they turn, it's still, kind of central. So these are all the different capsule types that come on the Shure mics, which is almost always what we get. And 183 is usually what you want to look out for because it's an omnidirectional, and you can see like the pickup pattern is drawn on there. It's picking up basically everything around it evenly, and it's going to create feedback issues. So if you ever see that, try not to use it. You could probably get away with it, but it's more dangerous. So what you usually want is a 184 or 185, and also you want all of your mics to be one or the other, because you just want them to act similarly. If if one person has a 185, you at least want to know that. And so the difference between these two is a 184 basically picks up a very narrow pattern around the mic like this. So if they turn that way, they turn this way, the mic might not pick them up as well. But it also helps you not get feedback into the mic. The 185 is wider, so it helps with, if people are turning their head, it's going to pick up their voice better. But then there's a little bit more issues with feeding back. But I like the 185 just because I'd rather have, be able to hear their voice and not ride the fader as they like turn their head all the time. And, it still gets rid of, everything underneath it. See, it's like kind of like a little upside down apple.
So the hypercardioid, when they turn their head like this, you notice a difference because it's directional.
Exactly.
And then the 185, which spits out,
it's like a cardioid.
just a cardioid, it's a heart shaped.
Yeah.
It's gonna get that bubble.
Yeah. So it's kind of like.
You get more bass from like the chest too with the 184.
Yeah, I mean you might, because it's basically a big ball that's like in all dimensions. So it's picking up, you know, the chest all the way out. You know, it's a big ball, three-dimensionally. And so, yeah, you might be getting, you know, more boominess from the chest, but I don't think it's really noticeable. So yeah, you've got, it's omnidirectional, there's a hypercardioid and a cardioid. So just, you know, you pop off the windscreen and you see which one you have. And then also any podium mics, Shure podium mics, they all have the same capsules. So if you need one from a podium mic that's not being used, you know, you just screw this thing off and throw it on one of your mics. So on to wireless kits. I'm going to talk about how to set one up and get good frequencies with and without Wireless Workbench, which is free software that Shure makes, and it does like a million things, and it's I'll show you everything that it does, but it's free, and as long as you like are bringing a computer to a show, you know, you should load it up. But let's say you don't bring a computer, you don't want to bring a computer, you get thrown into a room where you've got a bunch of mics. This is how to do it without the software. So basically, you power on all of your receivers. Let's say you got 4 of them. You power them all on, all your mics are off, and you hit scan on the first one. Then you take your mic, your lavalier, and you hit sync, and you put the 2 sensors together so that the frequency that it found, you know, matches up with your lavalier, and they're synced together. And you do the same with the handheld. Then you put those 2 mics either down the tech table or up on stage. Just don't have them sitting right next to the receiver, because you can get some intermodulation. So just put it like a few feet away is fine. Then you go to your second kit, and you've left that first mic on, and you do the same thing. You hit scan again, and it's going to find a new frequency based off of everything that's available, including avoiding that first one that you set on the first mic. And you just, you know, you sync up that mic with its kit, and you leave that one on, and you go put it on a table or a stage. And you just keep repeating that, and you know, until you're done. And basically that's the quick and dirty way to, you know, get good frequencies. So to check if those work, there's a method called the wargaming frequencies, and there's actually a video, and like you can watch it on your own time, but I think it's easier if I just explain it in a quicker way. What you do is all of your mics are synced up, they're all on. Let's say you've got your 4, and you go put them on stage or just away from the kits, and you turn off the first one, and you look at your meters, and if you're still getting signal with that mic off, that means one of your other 3 microphones is affecting that signal. If it does go totally down, then that one's good. And so you would turn that first one back on and move to the second mic, turn that one off, and see if the signal drops all the way down. If there's still a couple lights left there, you know, that means that certain frequencies aren't playing well with the other ones. And so if you got in that situation, what you would want to do is, let's say this is the one you turned off, you're getting a couple lights still, just rescan it. Hit scan again, and it'll give you a new frequency. Then turn it off again, and hopefully those lights will go all the way off. So you basically just keep all of your mics on, go through each one, turn it off, and make sure it goes all the way off. And ideally you would put them up on stage where they're going to be. So it's easier if you have a buddy to be up on stage turning them on and off and you're watching the kids. So then there's doing it with Wireless Workbench. And when you do it with Wireless Workbench, you can do it offline or networked. And networked is just you run a Cat5 from your kits to your computer. And if you have multiple kits, you can just either daisy chain them. If it has 2 ports on it, you can just daisy chain them all with little Cat5s and run one back to your computer. Or if they only have one Cat5 port, you can put them all into a little network switch and then run a cable from that network switch to you. But the network switch, all it does is it's just a way to distribute all those Cat5s. So right now I've got a Cat5 in the back of that kit and it's running straight to my computer, and I don't have a Cat5 port, but I just have it's just Thunderbolt to Cat5, or you can get a USB adapter to Cat5. And I'm going to show you in Wireless Workbench what it looks like. Okay. So let's say you didn't network them. You have no Cat5s running, but you want to use Workbench. The first thing you would do is there's these 3 main tabs. There's Inventory, Coordination, and Monitor. You start over on the left here, Inventory. And you say you want to add some devices. And you could do this, let's say they tell you exactly what mics are showing up, but they're not going to be here for a couple hours. You know, they say we got 10 mics, they're Shure ULXDs, and they're this band. You could build this whole thing, get all of the frequencies that you need before they ever get there. It doesn't have to be connected to the wireless kits. So you'd click on Add New Device. You say it's Shure. Say they're all going to be ULXD4s, and that's all on the front of the kit, all that information. And the band that's also on the front of the kit, and say they're all going to be G50s. And let's say we get 8 of them. So down here you just say I have 8 of those and I want to add them. And so these could be all the mics for your room, or they could be the mics for all the rooms. Let's say there's like 4 breakout rooms and they're like, hey dude, can you calculate all the frequencies? And you can do that because you just add them all into this session. And when you calculate these frequencies, they're not going to step on the other ones in the other rooms. And you're like, all these mics are going to be good no matter where we use them. So this is the one I have networked. You can see it's like bold, but we're looking at all these dimmed ones here. And you could label them up. This could be whatever, number 2, number 3, so you can identify them later. And so that's all you do on this tab. You're just adding them to your inventory of what you have. Then you go over to Coordination, and you click on this button and you say select the frequencies from that inventory I just built. Just bring them over to this tab now. So you click that, window popped up over here. But it basically says, do you want to do that? And I'm saying okay. And now they're all here. These are all my mics. And they don't have frequencies yet, but that's what this tab is for. So this is the one I don't want to change. This is the one I'm using right now. And the one that's networked. These are the ones that I added. And you can see the numbers, they pop up over here, number 2, number 3. And what we're trying to do is tell the software, hey, give me good frequencies for all these microphones. And so you just hit calculate. And it just populates all these frequencies. And since they all say compatible, you know all these microphones are going to work with each other. Even if they're in neighboring rooms, they're all good to go. And that's the thing with, you can't just pick different frequencies for different mics and say, well, they're different numbers, they're going to work together. When you pick a frequency, there's a big notch where that frequency is, and then it makes these tiny little mountains next to it over and over again, and those are the inner modulations. And it's just like harmonics in music, where you hit a note, there's like other kind of notes that kind of play with it that are at a lower volume. So the same thing with microphones. If one of those little peaks that repeats down the line, if one of those interferes with another frequency that you picked, you know, you're going to have problems. It's going to cut out. So this software basically calculates all that, which is impossible to calculate on your own. And it says all these are good to go. So what you could do is lock them all, say, okay, I'm going to keep those, and you enter all these into your kits, you know, each one. And that's it, you're good to go. And that's how you would do it offline. If you're networked, like this one, it got over here, it's down here. You can do the same thing, but I won't do it because I'm using it. And you know, you unlock it because you want to change it. You hit calculate, and it would give me a new frequency. The difference is you can then hit assign and deploy, and it'll send all of your frequencies to all of your kits. So you don't have to go into each kit and enter these frequencies. You hit one button, and if these were all networked, it would send all these into those kits, and then all you have to do is sync up the mic to it. So it's pretty easy to do because this software is free. Cat 5s are super cheap, and you know, you should network them if you've got a few mics going. And so the third tab is basically you can monitor everything. You can have everything on your computer, and you know, you can put your kits down underneath the table, or you know, you don't have to be peeking over at them, and you can see all the information. You can see this one's on, you know, someone's talking into it. Here's the audio signal. You can see the battery level. You can see if they're all set at the same gain, and you can see the frequency. And so it's just a good way to just keep an eye on things, you know, instead of looking over at the kits all the time. So you're at this point, and all of your mics work well together. But then there's always that question of, well, do other companies have other mics out there? You know, how do I know? Like, I can't get a hold of anybody. So you can scan. You can use your receiver as a scanner, and it scans the whole area and sees if there's anything else out there. And so you'd be in frequency coordination. You just click this little wheel here. And this is the only one networked. Yeah, so if you, let's say these were all the same band, all the same mic, I just had a bunch of them, you just have to click on one of them and use one of them as a scanner. And so when I click there, it showed that little, this is the range that it's going to scan. And my mic's not going to go to the recording right now, but I'm going to do this anyway. And I'll start a or, you know, these little peaks. And those blue streaks are just like the software saying to itself, okay, there's something to worry about there. And so you add in all these things. You add in the scan. You can add in the TV channels. You could add in
your own user presets too. Like if you got an RF, I'll save my questions.
yeah. If you've got something, you know, your own RF, or another company brings you a sheet with all their frequencies, you could add that here. Say, you know, also avoid these 10 frequencies that I know of. So you're adding all these things, and if you notice, all your mics aren't compatible anymore because it's saying, well, you got all this new stuff to avoid. We haven't analyzed it yet. So you add all those things, or just one of them. You could just do a scan, or you could just do the TV channels. And you say, well, analyze those frequencies that you gave me that first time. And it's saying, well, almost all of them are still good, but you should change, you know, these last 3. And so all you do is you keep those locked. You unlock the ones that you need to change. And you say, calculate new frequencies for me. Give me 2 more good frequencies based on all that. And now they're all compatible. And then you could lock those up. You know, they're good to go. And then, you know, you could hit assign and deploy again, and it'll send those 2 that were bad and, you know, replace them with good ones. So just, it makes all that faster instead of going into each kit and assigning it. This is awesome because you can look at everything. And you just feel more comfortable with, you know, that you're not going to get stepped on or anything. So let me close that. Let's see if this mic is still working. Okay. All right, so those are the 2 different ways. These are just some quick tips. You don't want to stack a bunch of receivers together. If you've got like 10, maybe do like, you know, 2, 2, 2, just kind of like spread them out widthwise. Because if you make this huge tower like a lot of people do, at least Shure says that you can get interference by doing that. It's not designed to be stacked up like that. All the antennas, you know, they're all touching each other, and it's not really ideal. So, you know, just kind of spread them out on a table if you can. Always keep a line of sight between the antenna and the mic. You know, you don't want something physically blocking it. So if you want to put it up on a little stand, or, you know, try to put those mics up on the switcher or something so that they're a little higher up. You know, always check your reception. Have somebody go up on stage and make sure your signal strength is good. And then, you know, people will throw in different mics and mix up the kit sometimes. So just make sure your antennas, your mics, and your receivers are all the same range. Because if they're from a different kit, they're never going to work. So, you know, if you're not getting signal sometimes, you know, you got to check that. And then there's a dip switch on every receiver for mic or line, and you can use either one, but just make sure you're either using all mic, they're all set to mic, or they're all set to line, because then when you start turning up the gain on the channels, it'll be all over the place. So this is just talking about gain throughout the board. You have all these different opportunities to change the gain. And what you're trying to avoid is clipping ever. So you want it high enough that obviously you can hear everything, but low enough that if somebody speaks really loudly, it's not going to max out and clip, and it's going to sound distorted. So, and some of these, like, there's a lot of text. Maybe you could read them later, because I think maybe I put too much on there, and I basically said the same thing. But I want to skip to, where was it? And then I'll go back.
That slide where you showed the ULXP4 plus 30 dB.
Oh yeah, that was crazy. Yeah, so that's from like Shure's website. They had a mic plus 30 dB, which is like crazy. You would never want to set it that high. Like maybe set it somewhere between like 0 and plus 10 if you need to.
It's like a hanging lavalier and a symphony.
Yeah, maybe. But like if you look at this here, this is the order I usually set these gains. So these numbers are what I start with. So I usually start with my speakers or amps, and I set it somewhere around 12 o'clock. So I have room to turn them up and I have room to turn them down. But I'll just start with that. Then I go to my mic, and usually I just set that to 0, no extra gain. And when I talk into that mic and I see signal here, what I'm looking for is somewhere around, these two dots. Maybe the top green light or this first orange light, somewhere around there. But usually I try to hit this green light so I have a little more room. So when this is set to 0 dB and I talk into that mic, that's about where I want to see it hit. So it's not even getting to the mixer yet. If you had it set at plus 30 dB, this is going to be clipping. And then if you're clipping...
You're going to hear him breathing like crazy.
Yeah, if you're clipping here, it's going to sound distorted there, and coming out of the speakers. You're never going to be able to come back from that.
There's some mics that'll have pads on them. So,
yeah.
We don't normally use those.
No. So then after you have that gain set, you're getting good lights on the receiver, you'd go to your channel gain, the gain on the mixer. And this is an analog mixer, but same thing on a digital. And you would turn that up. So there's a difference between an analog mixer and a digital mixer gain. On those Allen and Heath analog mixers, you've got some meters, and it's going to look like this. And these numbers are going to be there. Where you want to hit is somewhere around 0 on an analog mixer. But in the digital world, it's labeled completely different. These are the same amount of signal right here. It's just called -18. So it's labeled completely different. So if you're turning up the gain on a digital mixer and you're going up thinking, oh, I'm going to hit around 0, you're going to be completely clipping. So you just have to realize what kind of meter you're looking at. And usually I try to err on lower. If somebody gets really, really loud, I don't want that to ever clip. And I can always turn it up if I need to. So, I'll try to sit somewhere around there, maybe -18. But yeah, just try to err on lower, especially if these are meters on our recording. You'd much rather have it too low and have them turn it up, when they edit later, than to have it dangerously close to clipping. So I'm going to go back a few here. So once you have good gain on that meter using your channel gain, then you're moving on to the channel fader. But let me go to the order here. It's the channel gain, it's going to feed your fader next, but I keep that all the way down. This is going to be the last thing. As you can see, it's number 7. I keep that all the way down. And this is optional. This is if you're sending it to a group. So you can ignore that for now. But then you would turn up your output fader. So, just like your left, right, your mains, turn that up to 0. So now everything is set where it should be, except for your channel fader, which is still down. And so basically everything's set. I start talking into the mic as I slowly bring up that fader. And it might be loud enough in the room when I get to like -18. And I'm like, well, I wanted to get up to 0. That's where I want this fader to live. You know, that's a problem. I need to turn down the gain somewhere else. So let's say, you know, it's too loud in the room. It's just as loud as I want it at -12 here when I get the fader up to there. I would pull the fader back down, and I would say I need 12 decibels of gain somewhere else. And usually I would go to the amp or the speaker and turn that up 12 decibels. And when I go back here, I can bring up that fader all the way to 0, and now it's at the volume I want in the room.
Turn down there. Right?
Yeah. Did I say up? Yeah. Turn down the amp or speaker by 12 dB. You know, to give me 12 more over here. And so this is the reason why I want this fader at 0. It's called unity gain. And if you look at the numbers on a fader, this is the same physical distance. Let's say this is like 1 inch if you're looking at a fader. Up here, that's 12 dB, 6 to -6 of difference in 1 inch space. Down here, 1 inch space is 40 decibels difference. So, you know, that happens sometimes where you're just like, I'm just kind of lazy. It sounds loud enough. When I pull it up to -30, let's just start the show. And then you want to make these small changes, but you can't make small changes because you turn the fader down a little bit and you lose 10 decibels, you know? And the lower you go, the worse it is. So this is where you want to start, because you can make some pretty big changes on the fader and have there be small differences. So that's the point of getting this to sit at 0. All right, so I just explained this. So there's 2 other places you could turn it down instead of the amps or speakers. But it's not really recommended because these are other faders. There's an aux fader, you could turn it down, or the master fader, you could turn that down. But let's say someone comes in to operate your room or something, and they see, oh, why is the master fader at -10? And they push it up to 0, you know, and then pull your channel fader up to 0, it's going to be way too loud. So ideally you would go, if you need some extra room, you need to turn it up or down at the amps or speakers, because no one's going to go back there and change those gains. Okay, yep. All right, we're going to move on to EQ. So there's 3 main reasons we EQ. 1, avoid feedback. That's like #1 reason. 1 is some people just have annoying voices. You know, there's no feedback, but it's just like, oh, that guy's just so sibilant-y. I hate his little sibilants or his like honky voice or his boom. You know, all his B's are real big and B's. And you just want to get rid of that. And then we're going to talk about just eliminating unnecessary frequencies that we don't need. So when you're ringing out a room, there's basically a couple of ways to do it, that I do it. So one is by sweeping through the frequencies. I'm just going to show you on here. Okay. me flatten this first. Okay, so this is my mic right here. And so the Behringer mixers, they all come with this like RTA feature. So you can see where the frequencies are hitting. You can see what's like peaking over other ones. And it's by channel. So you can, you know, select another channel and, you know, see something else. So what I would start with, if I'm talking through this mic and it's coming out of the speaker over there, you know, I'm hearing audio. What's that? Okay. You know, I'm hearing audio, but it just doesn't sound good, you know. So what I would do is just start with a really low frequency. And I would, so you can see me moving down here. You know, I'm at like 40. And I can turn that up. And I make it pretty specific. I make that really small. And you can only change that on a digital mixer, the size of that. But make it pretty specific so we can find this frequency. And turn it up a good amount, maybe like 5 or 10 decibels. And then I just start sweeping through here. And it's the same thing on an analog mixer. You just can't see this graph when you do it. But you just boost one of your EQs and just start sweeping through the frequencies. So if you can see over here, I'm on the frequency knob, you know, going to different frequencies while I talk into the mic. Check 1, 2, 3, 4. Turn up the gain a little bit. Check 1, 2, 3, 4. Okay, there's something there. It's pretty annoying. It's ringing back. And it's telling me exactly where it is. And sometimes it's, you know, that's ringing back really hard. So you have to be ready to get away from it like that. Or if you can quickly, while you're on it, check 1, 2, 3. You just go down from there. So you're just kind of hunting for frequencies by boosting them.
Creating feedback to eliminate feedback.
Yeah, so you just make it as bad as possible. And let's say it was like a big range, like it's ringing back from like here all the way to there as I sweep through. You can, you know, make that, wider, you know, if you need to. So, you know, I found one, and then, you know, you've got all these different bands of EQ. And so maybe I would start from where I left off here, you know, create another one, make it really sharp, turn it up, check, you know, there's already another one. But that one's so close to the first one that, yeah, I'm just going to make that first one a little bit wider, take care of both of those. Maybe move a little farther down.
Split the difference too.
You know, there's stuff all over here. So let's say I just made that first one pretty wide to take care of all that. And so I'm just working my way back up farther. Check 1, 2, 3, 4, 5, 6. You know, maybe there's nothing else. And so then you found all your problematic frequencies. Maybe I get a couple of those and you pull them down. And so that's one method of doing it. The other method, let me go back to here. Oh no, I want to stay on here. The other method is using like an app. So I was using this for a long time. I mean, I still use it. It's just an Rta app, and you know, you can find them for free or they're like a couple bucks, and it's recognizing what frequencies are coming out. So I'm just going to put it down there so we can see it. But you know, I'll just put this next to the mixer, especially if I've got an analog mixer. Check 1, 2, 3, and it's just using the microphone from my phone. And when you click in this upper corner here, you turn on these crosshairs and it keeps finding the peaking frequency. Check 1, 2, 3, 4. trying to feed back. 1, 2, 3, 4. Check. 1. So you get the idea. It was like 450. So it tells me it's 450. I go to 450. I make a little notch, and then I would bring up my microphone even louder. Maybe bring it up to like +7. See if there's any other frequencies that are feeding back now. Maybe I get rid of another one. I pull it up to +10, and I get rid of another one. And so then I know that if I go all the way up to +10, on my fader, I feel pretty comfortable with, not getting any feedback. So that's just another way to do it.
Do you have the C weight on your RTA?
Yeah.
B weight?
So I think it's A weighted right now, but yeah.
Audio Technica has a really good multi-use app for free, and it's
Okay.
RTA and SPL, and there's like 10 different things this free app from AT.
That's cool. Yeah, I mean, that's useful too, to have like a decibel meter. If you're doing like a band or something and you want to know if you're actually getting louder in the room or your ears just, fatigued or what's going on, You guys want to take a break or something? Get some water and power through? All right. Cool. So there's two different kinds of EQs. The one I just showed is a parametric EQ. Let me go back. So there's a parametric and a graphic. They both have positives and negatives, and you can kind of use them both for anything you want, but just be aware of what they're actually doing, and I'll show you here. So this is just the method I just showed, but on an analog board. This is an Allen Heath board here. You would just start with those mid frequencies, turn them up a little bit, and then just start sweeping this around until you hear something. And let's say you hear it at 500. It's ringing back, you've got it dialed in right there, and then just turn that down, turn the gain down on 500. So on an Allen Heath, like, this is a parametric EQ. This is what's actually happening. You don't get this graph, but it's the same thing. This is just a visual of what's going on when you boost that signal. On a digital board, the one thing you get is you can change that Q width, and the Q is the size of that notch that you make. So you're able on a digital board to make it super wide, you can make it super small, and it's just, you can totally customize the frequencies that you want to get rid of. And so the Q value, actually a higher Q value is a tighter Q, and the opposite is true. So sometimes, you just want to get one frequency, or like we saw, sometimes there's a big swath of frequencies you want to get rid of. And then there's a graphic EQ. So when you have an analog mixer, sometimes, they'll give you a big 31 band EQ that you put your left and right out of your board into it, and then, you send the output to the speakers, and, it's just going to EQ your left and right speakers. On a digital board, you can put one of these on every single output that you want. You got endless amounts of these that you could put anywhere. So when you raise one up like that, these are all little faders. You push one up like that, the same exact thing is happening. Same thing as the parametric EQ. The difference is you have no Q control. You can't make that any tighter or wider. But a lot of times you feel like you can. So you turn up, and I have these up, but you'd have them down. You're cutting some frequencies out of there. If you put two of them that are next to each other like that, you'd think, oh, I'm making this nice little curve, like a parametric EQ. But this is what starts actually happening on a graphic EQ. You get this little notch. And when you start looking at a bunch of them together, sometimes you're trying to take out one of the, you're trying to make a wide Q. And so these little gray knobs, these are the little faders on a 31 band EQ. And you're like, oh, I have this nice little curve here. But this is what is actually happening. You're creating all these notches, and you're not actually canceling these other little frequencies that are in between there. So,
You're like a waffle so it doesn't take off.
yeah, so,
That harmonic distortion Eiffel Tower rise effect.
but you don't really want this, this waffle thing going on. You were trying to create something like that. And your faders look like that, and you're like, that should be what's happening. So this is better for if you just want to get rid of one frequency and another one here, and maybe they're more spaced out. You can start moving faders that are next to each other, but just know you start getting weird things like that. So if you were trying to create this, you would just use a parametric EQ and make that curve, and it's going to look like that, and it's going to sound like that. So this is just a graphic of what feedback looks like. So this is just a random level of where feedback is happening in the room. And this is this one presenter's voice. So it's pretty dynamic. There's these certain frequencies that are peaking just because of the characteristics of their voice. So as you bring up the fader, there may be a low talk, or you start turning it up, there's going to be one frequency that feeds back before the rest of them. And you've got to take care of that one first. So, you make your little notch, with your EQ or your graphic EQ, you pull down that frequency, whatever it is, like 400, and then that one gets lower. But then you have to turn up the mic even more, and that second peak shows up. This was the second highest one right here. So we flatten that one. Now you have to deal with this one because you turned it up even more. And you do the same thing. You get rid of that one. And then at a certain point, you can pull up your fader as high as you want, and it's all leveled out, for that presenter. You might run into the same issue for the next guy. And so, yeah, that's how you solve that problem. This is that app I just showed you. So then there's EQing for the sound quality, like I was talking about. Someone's just kind of boxy sounding, or this is just like a cartoonish representation of like this little range of frequencies. So this kind of helps because you don't, like, if you say, tell me what 320 sounds like, nobody can like just hum that out of nowhere. But if you say to yourself, well, I know it sounds muddy, like it sounds muddy to me, then to start searching in this area. Or, that's just, there's like an edge to it. It's like really hurting my ears. Just start searching in this area. Instead of just like being all over the map, like where is this frequency? Like this graphic is kind of popular because it helps a lot of people just narrow it down to a range instead of looking all over. There's like sibilants, and they've got those S's. You don't need to be looking around down here. It's in this range somewhere. So besides those other EQs, there's filters. And we use high pass filters all the time because like we were talking about, a human voice sometimes will only go down to 80 hertz. So from 20 to 80, there's a whole bunch of stuff that we don't need. It's, people futzing with their jacket. It's like people handling the mic. It's just all this super low end stuff that we just want to get rid of. So you could put this on anything. You could put it on every channel. You could put it on a group that you've made where you've sent all the handhelds to a group and put a filter on the group. And then you could also use it on speaker outputs. So, I don't want any of the low end coming out of my main speakers, and you could do a high pass filter on your sub speakers. You don't want any of that high end coming out of your subs, and it's less taxing on the amps, because they're like, oh good, we don't have to reproduce those frequencies, and the subs are like, oh, we can forget about all that, and it just sounds cleaner. Certain speakers reproduce that, other ones reproduce that, and you can hear everything. So that's what this is. Here are your subs, here are your mains, and you just, create a filter on both. So this slide, it's just something to keep in mind that just like a fader resolution differs, when you're looking at all the frequencies that exist that we can hear, this distance right here in the lower frequencies, that's a difference of 70 hertz, that difference right there, that distance. But that same distance up here, it's 7,000 hertz. And so just keep in mind that the lower you go, the difference between 70 hertz down here, you can hear that. Everyone can hear the difference between 30 and 100. But it's much harder to hear, almost impossible to hear the difference between 3,000 and 3,070. So it's just much more condensed the higher the frequencies go. So just keep that in mind when you're doing EQing. And then this is a really good website for just a whole bunch of audio stuff. You can test your headphones. If you've got like a good pair of headphones and you're wondering, are they still, something wrong with them? It like sweeps through all the frequencies. It checks, left and right balance. You can check speakers with it on a show, make sure they're all producing the right frequencies. There's all these hearing tests and noise generators, and there's just a whole lot of stuff on there. So there's 3 places that we can EQ. You can do it on a channel. You could do it on a group, like a mix, a group, or an aux, which are all, they're the same thing, but we're going to call it an aux. Or you can do EQ on each output, on each speaker. But we're basically going to talk about these 2. So channels, we all know channels are, each individual mic. But then you might want to create an aux. And that's just a group of channels. And there's 2 purposes for that. As far as AV, you can create an aux for all of your lavs, and then another one for all of your handhelds, and another one for all of your podium mics, another one for all the playback. And the reason you do that is you can just EQ that group, and then all of your lavs are already EQ'd, all your handhelds are already EQ'd. And you don't have to do it for each individual channel, like copy and paste. You just do it once. And then the other reason would be to group things together to go somewhere besides your main speakers. So if you're sending to a record deck, or just to your subs, or there's a speaker out in the hallway or something, So sometimes you're creating an aux to go somewhere different, not to affect the signal at all. You just want it going somewhere else. And then, you know, there's a post fader aux and a pre fader aux. You always see that button. And basically in AV, it's always post. Always use a post fader aux, because the trouble you can get in is, this is how it should be. Let's say you're doing an aux for records and you've got a post fader. That means it's after your fader. So you turn that fader up, it goes to the records. You turn the fader down, it's not going to go to the records. So everything you hear out of the speakers, that's what's going to go to the records. That's exactly what you want. So if you've got it pre-fader, that means it's coming off of that channel before the fader. So if you have that fader all the way down and you don't hear that mic in the speakers, that guy could be sitting with the microphone on in the front row, you know, swearing about someone, talking bad about somebody. He's not even on stage, and all that is going to the records because you did a pre-fader aux. And so no matter where you change this fader, you turn it up, you turn it down, it's always going to the records off of that channel.
Just wanted to be post fader always.
Post fader always. Pre-fader is usually only for like a band and for their monitors, where you're, you know, moving the faders for different levels in the house and you don't want it to change the levels in their monitor. So something where you just want to set it and forget the volume. Yeah.
Also the studio for signal processing, because you don't
Yeah.
want to change the fader and then then changing the level that it's hitting the EQ and changing the dynamics of that mix.
Yeah.
Or you don't have money for proper isolation.
Or that. No, it's fine. No, everyone's welcome to ask whatever they want. So yeah, don't do that. This is like a basic layout. When you get to a mixer, you've got all your channels. You know, these are each one of your channels: handhelds, lavs, podiums, and they just default. You know, they go to your mains, your left, right. And all of your EQ changes are on each channel. You've got to repeat that over and over and over, right? For each one. If you're using auxes, you free up all of these EQs. You can keep these all flat, and you do your EQing on the group, on the aux. So you do it once for the handhelds, takes care of all the handhelds. You do it once for the lavs, takes care of all the lavs. And same thing, and I usually try to group everything, and that way I can change things quickly for all similar inputs. And so these pink ones here, these are all, like I was talking about, these are auxes for groups. The orange are auxes for different outputs. So you've got record and you got subs. So like, you know, I only want, these are playback, these are like videos. The only thing I want going to the subs are the videos. I don't want any of these mics going to the subs. So I just send playback there. And let's say I only want to record these 3 handheld mics. I only send those to that aux. And then basically all these groups, then they feed the mains. So what you have to keep in mind though is these were all defaulted going to the mains. So what you have to make sure to do is turn off all of these going to the mains. You have to say, don't go to the mains anymore, go to these groups. Because if you have it going to the mains and the groups, then you've got 2 signals arriving at the mains. One is EQ'd, one is not, and you're going to be EQing and you're going to be like, what is going on? It's not affecting anything. Yeah, and you're going to get phasing because you have 2 of the same or similar signals arriving at different times. So you just have to make sure that it goes from here to there to there. And that's what I just said right there. Now, matrix is the same thing as an aux. Like for a while, I was just like, I don't want to do a matrix. I don't like the sound of it. You know, I'm just gonna do what I'm comfortable with. But it helps a lot because all it is more auxes. They're just usually all the orange type. They're just outputs. And so these are my matrices, these blue ones here. And so if I go to the next slide here, these are all outputs. So you've got a record, subs, and then all these. So these are, you know, physical XLRs that are coming out of your board or the stage box. You know, you would need this many outputs if you want to do this. And so going back to here, you know, this is what we had before. The channels feed the auxes feed the mains, and then your mains would feed out to all these other speakers. You know, you got front fills, delays, maybe a speaker in the hallway, and you would have control over all these individually, but you just turn up your mains and it turns up all these other speakers. The only issue is if you do an EQ here, it's going to affect all those. So sometimes I just make the mains a matrix also. And then they each can be EQ'd individually. You know, and you can make one a foldback and just send the handhelds to the handheld group and the handheld group to the foldback. Because that's the only thing you want, you know, for the presenter. You don't want anything else in that foldback. And it, you know, if you don't have a board, if you have a board that doesn't have any matrices, these can all be more auxes. So if you have a bunch of auxes, these can all be orange and be over here, you know? Let's say you had, I don't know, somehow had 12 auxes or something, which isn't going to happen, but you know, maybe you can replace this playback group where you don't have subs. You know, any of these can be an aux. So we're almost done, guys. Just so you know, there's like 6 more slides. So DCAs, those are only going to be on a digital board, and it's basically a fader on a board. And you could say, let's say you've got 8 table mics and everyone's going up to the table mics, and you don't want to push up 8 faders all at once. You set all those 8 channels to one fader, one DCA, and you can pull up that one fader and they'll all be up, and you can pull them all down with one fader. And you can, it doesn't have to be like mics. It can be a group of random mics. It could be channel 1, 3, and 7. And you put those all on a DCA, and you can control them all together. So the only difference is it's not, you're not grouping them together like an aux. It's just a remote control for those faders. Like the audio is not being routed to that channel or routed to that fader. It's just, I want to make this a remote control for these faders that I choose. And I could show you like how to do it real quick, but basically you just hold select on a DCA fader and then select all the channels that you want on that DCA, and then you let go of it, and then all of a sudden you have control over it. Yeah, so for tabletop mics, a U-shape, large panel lav mics.
You select the person on push button, you just jump through DCAs.
Yeah, so you could just have them, you know, you could put that all on your front page if you want, you know. On a digital board, there's different layers. So, you know, it could be on a second layer or a third layer, but you could you know, you can put any fader wherever you want on a digital board. So you could put that up on the, you know, on the front layer if you want to, you know, just so you have easy access to it. And a mute group is similar. You can put any channel on a mute button. So you might have like 8 custom mute buttons, and you say, all right, mute button number 1, I want it to mute, you know, all the lavalier mics, or, you know, just this one guy's mic, or like everyone's mic except for that main presenter. So you can totally customize it, and you hit one mute, and you don't have to be like, oh, mute that one, that one, that one, that one, or like pull down all these faders. You can just quickly mute things that you want. And then, yeah, it's pretty useful for a band. You know, if someone's singing and they have like reverb on their mic, and then they decide to like do a speech or something, you could mute the whole band and his effects. You know, mute that reverb, so that's just his mic without effects. And these are just some mixer tips here. You gotta, you know, be conscious of riding faders to avoid feedback. You know, if there's a bunch of people on stage, you can't just bring up a mic of someone that's talking. You kind of have to pull down those other ones, those other people that aren't talking, and, you know, be on top of that. Creating custom shortcut buttons, just like, you know, a mute group or a DCA. And then the custom fader layer, you can't do that on this board, but on most digital boards, you could put any, you know, any channel or any fader wherever you want. So like, you know, it could just be like 3 mics, your subs and your mains, you know, a couple DCAs. You could just, yeah, you could just totally customize it. Always be subtracting EQ for AV. You never really want to be adding anything.
The widest version of this console, you can do that too.
Oh, you can? Okay. Yeah, this is very similar to that, but a little bit different. You know, when you're troubleshooting, you're setting up a board, and the most frustrating thing is you're like, I don't understand why I don't hear anything, or I don't understand why I'm not getting this mic to this group that I want to get to. Pull up the meters page. There's a meters page. I'll show you on here. And it'll just show you where all of the signal is. So, you know, you're like, okay, I'm getting it on channel 1, and, you know, I don't have that many outputs or anything right now, but you can just see where all the signal is. You know, you can see that this is the record to Judd. You know, so you can kind of track down where your signal is or where it's not getting to, and that just helps a lot when you're first, you know, setting stuff up. And just like having just any pair of headphones is good, even earbuds. So you can mic somebody up and they go sit down, and you can like listen to them talk and make sure, you know, their mic isn't rattling, or, you know, it's, you know, it sounds good. You can hear them. It's on. I always tape power strip to the table. I stopped a show once I just like stretched out my legs and kicked the power strip off, and I didn't even understand why it stopped, because, you know, I was just like, I didn't touch anything, and yeah, all the power went out. So now I always do that. And then this is just 2 pages of tools that we went over almost all of them, but just good things to have, and most of them don't cost very much. Like even just like audio adapters, like that can save the day sometimes.
Female to female.
Yeah, turnarounds, but definitely, you know, like Sharpie and board tape, like, you know, and just labeling everything. You know, some people will be like, you don't need to label that, or like, don't spend your time labeling that. And I'd never listen to anybody, because if you don't label something and you want it labeled, you're screwed, you know? So I just label every side of every connection, everything.
You have to move your mixer, you have
Yeah.
your labels. It's like, okay, it's easy, it's not a headache.
Yeah, or like, yeah, we've got to move the whole mixer over to that wall.
Table over there? Okay, cool.
Yeah. And then here's some more tools. Most of it I talked about. You know, if you've got a tablet or iPad and a little wireless router, like the router I use, it was $20, and I can control the mixer from an iPad, and it works 90% of the time. Like if I go too far, it'll not work, but it lets you walk around the room and set those levels. You know, I want to turn up the front fills, or, you know, these subs are too loud, and walk the room and set all that up. And then this is all software and apps. So we talked about wireless workbench. There's a bunch of just offline editors for every mixer. So you could build templates for shows. You know, you could set up, you know.
Like I have the M32 manager.
Yeah.
Running on here.
So you could label a bunch of groups, you know, set up your handheld group, your lav group, you know, an output for your sub and your left and right, and just like save a bunch of time and set up a show, and you just put it on a flash drive and you can pop it in any mixer, and, you know, you're already halfway set up.
Have your predetermined lav EQ.
Yeah.
182 sure.
Yep. Yeah.
Ready to rock.
So just to have like a basic template to start from. I actually don't do it because I like to just start fresh, because sometimes I like forget that I set something in there, but I have done it where I've been doing a show and then I want to make a bunch of changes, and I put it on a flash drive, take it home and make the changes at home, and then bring the flash drive back, so I don't have to like hang around and do all the changes on the mixer, or like show up early to do it on the mixer. And then there's just some other things you can read through.
The Dante virtual sound card is really cool.
Yeah, that's cool. I mean,
There's also an AS50 Clark Tech to USB you can pick up.
yeah. And really, like, all the Dante stuff, for the most part, is total overkill for what we do. It's really designed for, like, doing,
Track recording.
well, that and just, like, networking audio through a whole building or an airport or something. But, like, but there's cool stuff. Like, you can do multi-track recording through a laptop, or, like, I do this thing where it's, like virtual sound checks. You can download a whole band, like a multi-track of a band, and play it into the mixer. And you could, yeah, you can mix a band over and over, you know, without the band being there. And that was about it. So yeah, if you guys want to like mess around on the mixer, you've got questions, that was about it. Yeah. Thanks, guys.